In this video, we will be discussing on how we can solve this partial differential equation. Now, using the Lagrange-Chappell method, we can say that we have dx over x is equal to dy over y is equal to du over x e to the power negative u. It means that we can generate set of ordinary differential equations from this equation. So our first equation will be dx over x is equal to dy over y. Let's call it equation 1. We have dy over y is equal to du over x e to the power negative u. Let's call it equation 2. And then we have dx over x is equal to du over x e to the power negative u. Let's call it equation 3. So we need to consider which of this set of equations can help us solve this problem. Now, we can see that from equation 1, it gives us some sense of separability, so it means that we can solve this ordinary differential equation. For equation 2, we realize that we have 3 different sets of variables. It means that using this equation to solve this problem will be a little bit difficult for us to do. So it means that equation 1 and equation 3 can help us to solve this partial differential equation. So let's start from equation 1. So we have the x over x is equal to dy over y. If we integrate both sides, we have natural log of x is equal to natural log of y plus a constant c. So we can say that c is equal to natural log of x over y, and that becomes our constant c. So we can use equation 3 also, so let's call this equation equation 4. So the x over x is equal to du over x e to the power negative u. So if I multiply it through by x, I have the x is equal to e to the power u du. By using the laws of exponentials, we have this. Now we have to integrate both sides to find u. But u is a function of x and y. It means that we will treat this equation as a partial integration because u is a function of x and y. So if we integrate both sides, we have integral of e to the power u du. That will give us x is equal to e to the power u plus a function of a constant. And then we have already defined our constant here. We have c, constant c. So e to the power u is equal to x minus f of c. And then if I take the natural log of both sides, I have u is equal to natural log of x minus f of c with the absolute sign. But we know that c is equal to the natural log of x over y. So we have u of xy is equal to natural log of x minus the natural log of x over y. A function of that. Because wherever we see c here, we put this one there. So we have, therefore, the general solution is u of xy is equal to natural log of x minus the function of the natural log of x over y. Now we need to find what constitutes this function in order to get the particular solution. So given the Cauchy data, we have u of x squared is equal to, so this corresponds with x and this corresponds with y. So wherever we see x here, we put x. Wherever we see y, we put x squared there. So you have natural log of x minus f of the natural log of x over x squared, and then we have this is equal to 0. So we have the natural log of x minus f of natural log of 1 over x is equal to 0. And then we can say that we have e to the power 0 is equal to x f of the natural log of 1 over x. Now we can say that e to the power 0 is equal to 1, so we have x minus f of the natural log of x to the power negative 1. And then we can say we have f of x to the power negative 1 for the natural log is equal to x minus 1. So we need to get a function so that we can evaluate this whole thing there. So we have, let w be equal to natural log of x to the power negative 1. So if we simplify this, we have w is equal to negative 1 over negative natural log of x, and then we have natural log of x is equal to negative w, and then we have e to the power negative w is equal to x. So quickly we need to go back to the normal function, because we said we are letting all this be equal to w, and then we know the definition of x. So we have f of natural log of natural log of x to the power negative 1 is w, so we put w there. We have x replacement is e to the power negative w minus 1. Now if I give you any function such as f of x is equal to x plus 1, then I tell you to find f of 1. You quickly say f of 1 is equal to, f of 1 is equal to 1 plus 1, and that gives me 2. We are using the same idea, but in this case we have this function and we are trying to evaluate at that. We are trying to evaluate at this. So now we have f of w is equal to e to the power negative w minus 1, and we are asked to find f of natural log of x over y. So it means that this constitutes that. So wherever we see w, we put this whole expression there. So we have e to the power negative natural log of x over y minus 1. And then by the laws of exponential, if I have a over b all to the power negative 1 is the same as b over a. So in this case we have e to the power natural log of x over y to the power negative 1 minus 1. And using this principle, this goes up and then this goes down. We have e to the power natural log of y over x minus 1. And then if I have e to the power natural log of x is equal to x, so this represents our s in this case. So we have y over x minus 1. So it means that wherever we see all these expressions, we can substitute this. So we will come back to our general solution and then we replace it with that. So therefore, our particular solution is u of x y is equal to the natural log x, and then minus is a double term, so we bring y over x minus 1, and then that gives us natural log of x minus y over x plus 1. So we can rewrite it as plus x plus 1 minus, and that becomes the particular solution.